Okay, again, here's the next video that I promised after the previous one, right? In that one, we talked about special kinds of vector field, actually special case of vector fields, and it was called a radial field. This next video, I want to start this one maybe by way of an example using a little bit of math that we did back in chapter 13, okay? So I'm going to introduce the second special vector field by way of an example, okay? Okay, suppose we have the surface z equals phi of xy is equal to x squared plus y squared, okay? Now, from our work in chapter 13 and from our table of special surfaces, we know that this is going to be a paraboloid and it's going to open up, or it's going to look like a bowl shape. And a quick sketch of that. Like this, okay? The next thing I want to do is, can you remember this? I want to generate some level curves of this, right? So I want to choose some specific values of z, constants now, right? And those are going to represent planes that we're going to slice through this surface. And where those planes intersect the surface, remember those are called traces. And we're going to project all those traces down onto the xy plane. You have an idea of what those traces might be? Right, so choose some constants for z, like maybe 1, 4, and 9. Just something easy. What do you think those are going to be? Yeah, circles, gang, good, circles. So for example, for z is equal to 1, that would be like right here. Okay, the trace like this. And then, of course, you project that down onto the xy plane. Okay, so that would be the circle centered at the origin, whose radius is 1. For z, for z is equal to 4. Okay, that'd be about up here. All right, that level curve projected downward. So the next one would look like this. So what you're going to have then, gang, is you're going to have concentric circles, okay? Now, here's something else that we did in chapter 13. This was when we were talking about directional derivatives, okay? Find the gradient of the function. Find the gradient. Remember what that was? Okay, so what would that be in this case? Looks like we're going to get 2x plus 2y. Okay, gang, notice from the previous video, this has the form of a radial field. Okay, that has the very form of a radial field. Go back and look at the previous video, right? Look at the section in our textbook. That's the radial field 2 times xy, okay? The gradient of that function, x squared plus y squared, is itself a vector field. And for that reason, gang, when you construct a vector field in this way, they're referred to as gradient fields. Here's something else that's interesting, I think, right? And you might think so too. I know you do. Okay? We proved one time for all time what was true about gradient vectors in relation to the level curves. We proved that the gradient would be orthogonal or perpendicular to every level curve at every point where they're all defined, okay? So here's what I'm going to do again. I'm going to take these level curves right here. I'm going to rotate so that the z-axis is coming out at us. Okay, there's the level curve at x squared plus y squared equals 1. There's the next one, and so on, and so on, okay? What are these going to look like, right? What will those look like? Well, at any point that's on those curves, that vector should be orthogonal to the curve. Let's just try one, and I'll highlight it in green, okay? So gang, I'm going to take a point that I know is on the inner ring right here. Let's choose this point right here. Okay. Okay. So that's the same as this. So from that dot then, gang, I'm going to go no units in the x direction, the horizontal direction, and 2 units upwards. 1, 2. Okay, yeah, just like that. Okay, notice orthogonal to the curve itself. All right. How about this one? Okay, where would that go? Yeah, good, right here. Right, this is -1, 0 right here. What's the vector that is associated with that? Where is it? Right here. Okay, so from this, I'm going to count no units left and 2 units. Ooh, what is that? Did I get that right? Oh, I got I got it switched, gang. Got that switched. Yeah, you know when you make a mistake, soon as you say it, right? Soon as you say it. Okay. So from the point -1, 0, I'm going to count 2 units to the left and no units up or down for that matter. Okay. And again, on and on we can go like this. Here's what I encourage you to try. Input this vector field into Desmos. Okay. Next, put some level curves in there as well. Put some concentric circles in there. Put x squared plus y squared equals 1 like we did. Put x squared plus y squared equals 4. Maybe one more, x squared plus y squared is equal to 9. And then look at all of the vectors that are generated in relation to all of these level curves. And you'll see exactly what I'm talking about. Okay. So the second special case of vector fields are gradient fields. Okay. Okay, gradient fields. And we'll see more about these. We'll talk more about those in subsequent pencasts and especially through the examples in the exercises. Okay? All right, gang.